Hi everybody, this is Mrs. Huggins and I'm here to talk to you about using bar models to solve word problems. We are starting this process and it's going to seem kind of easy to you because I know that sometimes you can look at a problem and see whether you should add or subtract, but as you get older this is not going to be so easy and sometimes the words can be a little bit misleading based on the information that's given in the problem. So I'm using some of these easier problems and I'm going to teach you how to do the bar models so that when you get to more confusing problems you'll be able to use them to help you. Now, I want you to read this with me. Let's look at this word problem. Kevin scores 78 points in the first game he bowls. He scores 85 points in the second game. How many points does Kevin score for both games? Now, hopefully you remember that if you look at this question, you can kind of see what this question is asking us. This is asking us to find Kevin's score for both games. And I know most of you are probably going, Miss Huggins, I know, add. And yes, this is going to be an addition problem. But again, the point is we're learning how to set this up in a model so that we can solve more complicated problems in the future. So the first thing that we need to do to solve this problem is we need to draw ourselves our unit bar. This represents what the problem is about. And if you look here, we can look at the question to see what the problem is about. We're trying to find out Kevin's score for both games. So the first thing we want to do is label. We're wanting Kevin's score. So let's label this bar. We could label it score. We could label it points. I apologize for the messy handwriting on the iPad. I'm going to call this bar points because that's what I'm going to try to find out. At the end, my answer is going to be something points. That's my unit. That's going to be my answer to this question. So if I look up here and I go back to the problem, I'm going to start underlining some key information. I know that Kevin scores 78 points in the first game. I see that he scores 85 points in the second game. And then my question is how many points does he score in both games? And I see there's my missing information. That's going to be my question mark. I can see from underlining all of this that I have two parts to this bar. I'm going to label them. I'm going to cut my bar in half and I know he has some points for the first game. I know he has some points for the second game. And then I can see right here with my question mark that for both games combined, the length of this whole bar is going to be where my question mark is going to go. Now I can go and I can take this information and fill in my bar model. Kevin scores 78 points in the first game, so I'm going to put 78 right here. And then in the second game, it tells me he scores 85 points in the second game. Now I know because we've been talking about this is like a fact family. If I have part whole, here you can see it, part equal this whole bar. If I know two parts and I am missing my total, I know that I can add. So I'm going to come over here to the side and do my work, and I'm going to do 78 plus 85. And I'm going to add. 8 plus 5 is 13. I have to carry the 1. 7 plus 8 is 15 and add the 1 that was left over, which makes 16. So my answer is that Kevin scores 163 points. That is a basic part whole word problem where we know two parts, and we're missing our whole. That tells us to add. Okay, I'm going to show you a different problem on the next slide. Okay, now let's look at this next problem. And again, as I say, read the problem first. Do not start solving anything until you've read the entire problem. There are 147 fish in a pond. 49 of them are black. The rest are orange. How many fish are orange? Okay, I've read my problem. Now I'm going to go back and I'm going to look at some information. I'm going to start looking at this first sentence and find out what's important. There are 147 fish in a pond. That's important. That's a number. That's important. 49 are black. The rest are orange. How many fish are orange? There's my question mark. How many are orange? That's what I'm trying to find out. So that's where my question mark is going to go. I can see by looking at this problem that I have three pieces to this problem. Fish in a pond right here. black fish and orange fish. So now I can go start drawing my model. I can look and I can see, okay, now I've got a bar. I know I have 3 parts to this problem, so I'm going to go ahead and cut my bar into 2 parts, and then I know I'm going to have this hole up here. I've got to just figure out where to plug my numbers. So I like to start by looking at the question and think, what am I talking about? Well, my question is, how many fish are orange? I'm going to be saying blank fish are orange. Blank fish are orange. What am I talking about? Well, I'm talking about fish. I can see from this problem that I've got some black fish and I've got some orange fish. I've got black fish and I've got orange fish, and then I've got the total number of fish. That's the 3 parts to this. Now I can go and start plugging in my numbers. There are 147 fish in a pond. I ask myself, is that all of the fish or is that part of the fish? Which one is that? Well, I can look and I see if I have 2 parts, a black part and an orange part, 147 is going to be all of my fish. So I'm going to put that in my total. That means of all the fish, the black and the orange, 147 is all of them. Now I can look here. I see 49 are black, so I'm going to come over here and I'm going to plug 49 into this part, and then it says the rest are orange, but I can see right here that my question mark tells me that's where that goes, in the orange part. Now, if I were to set this up part, whole, I can see 49 plus something is going to be 147. Well, if I have 2 parts in a total and I'm missing one of my parts, I'm missing an addend, I can do the opposite of addition and do subtraction. I can do 147 minus 49 to figure out the other part. I see some regrouping here, so I'm going to regroup. 17 minus 9 is 8. Again, 3 minus 4, I can't do that. More on the floor, go next door, take 1 away to get 10 more. 13 minus 4 is going to be 9. 0 minus nothing is 0. I don't write that. I can see that I should be correct in saying 98 of the fish are orange. I can always go back and check myself and think, well, if that is supposed to be 98 and I see part, whole, I can add my 2 parts to make a whole. So I'm going to check that with addition. 9 plus 8 is 17, carry my 1. 9 and 4 is 13, and 1 more is 14, and I ended up with my total. So I must be correct that 98 of the fish are orange. So this ended up being a subtraction problem, and I could tell that by looking at, I know a total, but I am missing a part. A missing part or a missing add-in that you can see right here is going to mean do the opposite or inverse operation, and the opposite of addition is subtraction. So let's look at the next problem. Okay, for this last problem, this one can get a little confusing, so pay close attention. Let's read the problem. The library spends $225 on books. It has $78 left to spend. How much does the library have at first? Okay, I want you to really think about that. Have at first and where that might go in a bar model, where that at first would start with. So I'm going to look back. I'm going to underline some of these parts of this problem. Okay, the first part I see is the library spends $225 on books. It has $78 left to spend. How much does the library have at first? And there is my question mark. The way I'm going to answer that question is the library has blank dollars at first. All right, so I can see from my answer to my question that I'm talking about money here. So I'm going to go ahead and draw a bar, and I'm going to call this money. We're talking about money. Okay, now we can go back and kind of look at the question. I see 3 parts once again. I can see that the library spends some. I can see that it has some left to spend, and then I'm wanting to know how much it has at first. So I've got to think, where is that question mark going to go? am I trying to find out all of the money the library has or part of the money the library has if I'm trying to find out how much they have at first? Well, if they're starting with a bunch of money, that's going to be all the money the library has. So that question mark is going to be our total. And then I can see that I have two parts. I know that the library spends a certain amount, and then I know they have some left to spend. They still have some left over. Think about if you go to the store and your mom gives you some money and then you spend some of it, you would have some left over that you could still spend. So if I count what I've already spent and what I have left to spend, that should tell me what I started with. So now I can fill in my numbers. I see that the library spent $225. I know that they have $78 left to spend. If I combine those two things, part, to find my whole, part, whole, I can find out how much the library started with. So this is an addition problem because I know both of my parts, $225 plus $78. I can add 8 plus 5 is 13. 7 plus 2 is 9. 1 more makes 10. 2 plus 1 is 3. That is $303 that the library had at first, or what they started with before they spent any money. So this ended up being an addition problem. Sometimes you might see that word, well, this is what they have left. Some people think that that's a subtraction problem, that if you have some money and you spend some, what you have left is a subtraction problem. But again, the question was how much did they have at first? So we had to put that question mark in the right place to see where to plug in our information and know that this was an addition problem. I hope that this has been helpful. I'm going to make some more videos on other types of bar modeling. These are just part, whole. Use these if you need help with your homework or need to remember how to set things up. We're going to get into some add-on and takeaway and comparison models coming up. So I hope this was helpful. Bye.